Hey guys, this is video 1.9. We're going to be talking about dimensional analysis. This is a technique that is super useful. It's maybe brand new for you, and the first few examples that we do may be so easy that you're like, I don't need to do this. I'm telling you, you got to trust me. I know it's early in the year for you guys to kind of, for me to be like, hey, trust me on this. Ask students who've already taken the class how important this technique is. This is something we're going to use. We will have 4 or 5 step problems later on in the year that if you can master this now, it's going to make your life a whole lot easier. Work through it, ask questions, do a lot of practice to make sure that you can master this now and not, be suffering later on. Dimensional analysis is also called factor label. You'll also hear me refer to it as conversion factors. Okay, or conversions, where we use conversion factors. So a conversion factor, guys, is just a mathematical expression that relates 2 units that measure the same quantity. So something that you would be familiar with is like 1 minute equals 60 seconds. 2 different numbers, 2 different units, but you know they're the same thing. Or we could say that 1,000 grams equals 1 kilogram. Or we could also say like 1 liter equals 1,000 milliliters. Maybe you can kind of think of other ones like 24 hours in a day are equivalent, so they're the same thing. All right. Because they're also known, like I said, as conversion factors, factor label, unit conversions. You're going to hear me call it a T-chart a lot, where we're going to actually make a chart that looks like a bunch of T's. You'll often be required to solve a problem that has mixed units, or to convert from one set of units to another. So the big thing, you're going to hear me harp on this all year long, let your units drive your math. You might be like, I have no idea what that means. So if you hear me keep saying it throughout the year and you're like, I have no idea what let your units drive your math means, don't just sit there and be like, well, I'm just going to ignore it. Ask me, say, hey, can you explain what this means again? Okay, and I'm going to show you that here. So let's take a look. How many minutes are there in 15 days? So there's kind of a few steps that are going to go into this, and having a game plan in your head is going to make it a whole lot easier. So I want to figure out minutes. That's kind of my goal. So it helps to kind of think in terms of like given and wanted. Okay. So we're going to figure out the unit that we have, and then how many steps we need to do in order to get to the units that we need or that we want. Okay, and these terms, guys, given and wanted, are going to come back later on in the year when we do this thing called stoichiometry. Yeah, I know you're probably laughing like, whoa, that's a weird word. It's the backbone of chemistry. Okay, so given and wanted are going to be something that's very useful to start thinking about. So if I have given, which looking at my unit, this is where units are going to drive our math. So before we do any number crunching, we're going to get our units set up. That's what I mean by letting your units drive your math. Days are what we have first. I'm just going to abbreviate it as a lowercase d. And then we want to get to minutes. Okay, well, do they correlate directly? Now, you may know how many minutes are in a day. Most people don't. But we know that, hey, days relates to something else in between. Hours. Okay, and then hours and minutes. So there's that missing piece. So when you solve a problem in chemistry, all right, you got to kind of think, okay, this is where I'm starting, where do I want to get to, and then where do I need to go in between to get me to where I want to be, okay? So it's kind of like a roadmap. Now, you're going to just be thinking about this in your head eventually, but if it helps you to write it down now, write it out like I've done here. Step 2, we're going to make a T-chart. Okay, we're going to set up our units, then followed by our numbers. The number and the unit you have goes first in the far top left. So here's what a T-chart's going to look like. Okay, bam, it looks like a big T. So what we have, or our given, goes up here. So in this case, we have 15 days. Over our first fraction, notice how if I were to get rid of this line right here, guys, don't do that. You can leave it like that. Okay, this is the same thing as what I did with the T-chart. So wherever you see a T, that just means multiplication. Okay, you're multiplying in here. So these are fractions. We're going to be multiplying by fractions. So to keep us from getting confused, always put a 1 down here in the bottom. Okay, it's a placeholder. And I'm going to change colors to kind of reiterate that. This is a placeholder. so that you don't get confused and write anything down there. This is something that's helped so many students out in the past. I encourage you guys to do it as well. Okay, there will be a special case or two where we actually do have that, but most of the time we're not going to worry about it. So what we have goes first in the top left. The number and the units you want go in the top right. So for this, we have one step here, and we have two steps. So our first step is going to be to convert from days to hours. So the unit I want to get over here goes on the top, and the unit I'm trying to cancel out will go on the bottom. Because you guys should remember from math class, if I have something on the top of a fraction and the bottom, they're going to cancel out. So my days will be gone. All right, so now we've just got to figure out, all right, the conversion factor, i.e. the numbers that go in the bottom right. So one day, we should know that has 24 hours. Okay, so again, this is what we need. And then this bottom part is our conversion factor that we're trying to cancel out. Okay, so that's the basics of our T-charts that we're going to use. All right, step 3, I kind of already said that. We're going to cancel out our like terms. Then we're going to multiply. So this is really going slowly, kind of breaking it up step by step. You're going to see as we do a couple practice examples together that I'm going to kind of write it a little bit more fluidly. Okay, so the numerators together, and then we're going to divide the result by the denominator. If you have multiple denominators, multiply them together first, and then divide by the new fraction. We'll get more into that later on. So if I have my T-chart, so 15 days, 24 hours, 1 day, my 1 goes here. So we canceled out the D's because those units are gone. So now we're going to be left with hours, which is good. It's getting us closer to minutes. So 15 times 24 gives us 360 hours in 15 days. All right. Just a side note, since there are 24 hours, since 24 hours and 1 day are equivalent, well, all you're doing here, you're actually multiplying 15 days by a factor of 1. All we're doing here is multiplying by 1 because those 24 hours in 1 day are equal to each other, so that's like multiplying by itself. It's just changing the unit. That's all we're doing here. So this factor label method, guys, allows us to convert units. Step 4, did this get us to the unit we want to be in? No. So we're going to do the same process over. We're going to set up another T-chart. 360 hours is our given. Put our 1 there as a placeholder. Okay, now we want to get the new, that's the new half. I'm jumping around here. Answer from step 3 is the new half. Repeat the process using conversion factor of 1 hour. So again, look to see, okay, hours is on the top. It needs to go on the bottom so we can cancel out. The wanted unit goes on the top. So 60 minutes, 1 hour. Do the math. Remember, anytime you see a T, it's multiply. So 360 times 60 is going to give us 21,600 minutes in 15 days. And that would be our final answer. Okay. Now, we can't just make one long chart. So instead of splitting it up into kind of steps 3 and steps 4, we could have written it out like this, where we went 15 days. There's my placeholder. So day went on the bottom, hour went on top. So 24 hours in 1 day. Okay, and I could have just put the next chart together here, where hour now went on the bottom and minutes went on the top. So 1 hour has got 60 minutes, and then I can just multiply it all together. Okay. Now you may want to break it up into multiple steps first, but eventually, guys, this is the method over here where you're going to want to try to get to. Okay, you want to be able to get it in one long one because that's what we're going to do later on. So if you feel confident in this, pause the video, try this you-try problem. If not, I'm going to go through it here so you'll work it out with me. So we want to figure out how many minutes are in the month of October. Okay, so think about we have month, wanted is minutes. So my given is month, my wanted is minutes. So I'm going to put minutes all the way over here as a target point of what I'm trying to get to. So I'm going to say 1 month, or you could have said like October month, because that will come into play here. Start with the basics, okay? Everybody can do this because this is what you were given in the problem. All right? So 1 month over 1. Now go from here. Well, do I want to stay with months? No. So if I don't want to stay with month, where does it have to go in my next fraction? Well, it's on the top in the first one, so it's going to go on the bottom in my second one. And then month relates to what? Well, what's the next unit down from month? That would be days. Now this example, guys, is maybe a little confusing because not every month is the same amount of days. So you got to look at October. How many days are in October? Well, think the old rhyme, right? 30 days has September, April, June, and November. All the rest have 31 except for February. So there's 31 days in that 1 month. Note how month has been canceled out, so that's no longer our unit. Well, is days the unit I'm trying to get to? No, so I'm going to go to the next one. We'll break down days. What comes next? Well, days on the bottom, hours would be the next unit. Days will cancel out. In 1 day, I have 24 hours. Okay, moving along, but is hours where I want to end up? No, I'm trying to get to minutes. So I got to break it down even further. This is where that T-chart really comes together because instead of writing, 4 different equations, we can just write it all as one line and then go back and do the math. Notice I haven't really done any math yet. And every time, guys, I set up a new conversion factor, a new fraction, I get my units set up first. The numbers follow the units. So hours on the bottom to cancel out, minutes would go on the top. Hey, look, that's what I'm trying to get to. Boom. So 1 hour, 60 minutes. I can write equals. Now I'm going to go back and do the math because my units have been all canceled out. Okay, I don't have anything that's not canceled out except for minutes, which is what I'm trying to get to. Now I can go back and do the math. 31 times 24 times 60. I don't have any numbers on the bottom except for 1, so I don't have to worry about dividing here. When I do that math, I get 44,640 minutes. Now you might be thinking to yourself, well, don't I have to put that in proper sig figs? No, unless the problem asks you to round it to correct sig figs, you don't need to worry about it. So I want you guys, try these 4 problems on your own. Note, in the next video you may see, I will talk about double unit conversions. Those are for those of you thinking about AP. This is your first AP extension. So if you're thinking about taking AP Chem, you may want to get the notes for the double unit conversions and then try those on your own. If you're not thinking about AP Chem, don't worry about it. Go on to the next video. Till next time, I'll see you later.